Hi, welcome. Today I'll be showing you another usage of Smith chart, which is open and shunt stub matching network. This is a generic layout of open and shunt stub. The aim of this calculation is to calculate the distance between Z load and the shunt, which is D, the length of the shunt, which is L, and in order to find those two, we need to calculate or find what is the value of YD and YL. Steps of open and shunt stub matching network. First, locate the normalized load impedance ZL, draw constant Vswr circle and locate YL. Move clockwise wavelength towards generator along Vswr circle to intersect with 1 plus JB. That's the value of YD. Next, the length move from YL towards YD is the through line length, which is D. Locate YL at point plus minus JB. Depends on shorted or open stub. Move along the periphery of chart towards YL, wavelength towards generator. And lastly, the distance traveled is the length of stub L. Okay, given a transmission line with ZL is equals to 100 plus J 100 ohm and Z0 is equals to 50 ohm. So since our network is not matching, so we need to do a stub. So today we're going to do open and shunt stub. So how to do open and shunt stub is just to put a open and shunt stub and the shunt is in open end. Okay, so we're going to calculate what is the distance suitable ZL to our shunt and what is the length of our shunt. Okay, first step we need to do is to plot normalize impedance. Okay, so normalize impedance is our ZL prime. So ZL prime is equals to ZL over Z0, which is 100 plus J 100 over 50. Okay, so you will get 2 plus J2. So we need to plot 2 plus J2 at our Smith chart. So this is our Smith chart. Okay, a bit blur here. So 2 plus J2. Okay, from our real part, this is 2. Okay, and J2, look at our curve here. So 2 is around here. So 2 plus J2. Okay, so we plot 2 plus J2 here and label it as ZL prime. Second step that we need to do is to draw our Vswr circle. Okay, once you have drawn your Vswr circle and draw a line from Z0 to ZL prime. Okay, once you have drawn your Z0 to ZL prime, from here we can calculate our YL prime. Okay, so here I will try to self-check my YL prime. YL prime is 1 over ZL prime. So 1 over 2 plus J2. Okay, you will get around 0.25. Okay, 0.25 minus J 0.25. Okay, this is the value of calculated. So we want to measure it at our Smith chart. Okay, so we have to draw first our VSWR circle. Okay, use our compass. Put it in the middle or our Z0. Place our pencil at our ZL prime and draw the circle. Okay, so we have drawn our VSWR circle. So next we're going to draw a straight line from Z0 to ZL. Okay, so this is our J2. So I'm going to extend this until, okay, I'm going to extend it to find my YL. So YL is 180 degrees from our ZL. Okay, so now plot or draw a straight line from the bottom until the upper side. Okay, so this is your ZL. 180 degrees from your ZL prime is your YL prime. So label here YL prime. So if we're going to measure our YL prime, okay, this is 0.2, 0.3. Okay, so 0.2, 0.3. So I can say it's in the middle, 0.25. Since it's in the lower half, so it's minus J. And look at our arc here. This one is 0.2. Okay, this one is 0.3. So I can say yes, it's also at 0.25. Okay, so compare it with our calculation, you will get 0.25 minus 0.25 J. So it's you are in the correct direction. Okay, so next we're going to, okay, we're going to rotate. Okay, we're gonna rotate our YL prime, okay, towards generator to match real part. Okay, so back to our Smith chart. Okay, this is our YL prime. Okay, let us see. Our we were told to use wavelength towards generator. Okay, so we're gonna use wavelength towards generator. So we have to see what is the distance or where is our YL prime. So wavelength towards generator, we are going to read the outer part of the scale. So 0.46, 0.45. This one is 0.46. So I can say it's at 0.468 lambda. Okay, 0. Sorry, not 0.5. Okay, 0.58 lambda. Okay, so we're going to rotate our YL prime to the first intersection of VSWR and our match real part. Okay, so our match real part, okay, is at 1 plus JB or 1 minus JB. Okay, so from our YL part, we rotate it at wavelength towards generator. Okay, from here we're going to go for clockwise. So the first intersection that we meet is this point. Okay, not this one, because if we go anti-clockwise, that will be towards the load. Okay, this one, wavelength towards the load. But we're going to go for wavelength towards generator. So we're going to go for clockwise. Okay. So since we're going for clockwise, so the first intersection is here. ZL prime, sorry, up here. Okay, so I'm going to label that. That is our YD. Okay, so we need to draw from the center point to YD. Okay, from the center to YD. So once you have draw your line, then we allocate. Okay, where is our YD? So again, using wavelength storage generator, move along the outer scale. This is 0.17. This one is at 0.18. So going nearly to 0.18. So I will take it as 0, sorry, okay, 0.179 lambda. Okay, 0.179 lambda. So we need to calculate what is the distance from YL prime to YD. Okay, so this will be from here up to here. Okay, this is the distance of D. So the distance of D is from 0.48458 lambda, and we're going to the maximum part. Okay, the maximum part is this one is 0. Okay, half circle is 0.25. So finish up one circle, so it will be 0.5. Okay, so from 0.5 back to 0, and we add up until 0.179 lambda. Okay, so rotate. Just now we mentioned YL prime is at 0.4458 lambda. Okay, 458 lambda, and our YD is at 0.179 lambda. 0.179 lambda. So the distance D is equals to 0.5 lambda minus 0.458 lambda, and plus back with 0.179 lambda. Okay, so 0.5 minus 0.458 plus 0.179, you will get 0.221 lambda. So the distance from from Z load to our stub is 0.211 lambda. Okay, once you have calculated D, then next is you want to calculate what is the length of our stub. So step number 4. Okay, step number 4 is you want to plot where is your YL. Okay, so YL is, you have to take Y total, okay, is equals to YD plus YL is equals to 1. So our YD, okay, YD is here, so we have to identify uh, the coordinate of YD. Okay, so looking, YD is at 1.0 circle, okay, and it is on upper side, so it's here 1.6. So 1 plus j 1.6. So our YD is 1 plus j 1.6 plus YL is equals to 1. So YL is equals to, okay, 1 minus 1 plus j 1.6. So you will get minus j 1.6. So we plot our YL at 0 minus j 1.6. 0 is the outer circle. Okay, why it is outside? This one is 0.1. Okay, so this is 0. So 0 and minus, it's on the lower side, minus j 1.6. So it's here. Okay, so we will label that with YL. Okay, YL. So once you know where is the coordinate, the location of our YL, so use our ruler. Okay, draw it from the center, bring it to our YL. Okay, draw our line YD to YL. Okay, so we need to use the same rotation, which is wavelength towards generator. Okay, so wavelength towards generator from wavelength towards generator, we read the wavelength towards generator scale. So our YL is set 0.33 until 0.34. It's in the middle, so the value of YL is at 0.339 lambda. Okay, 0.339 lambda. All right, so how to calculate our L is look back at our stub. Stub is open and shunt. Okay, open and shunt. So remember from previous lesson. Okay, this is our Smith chart. This is uh our real part. Okay, the left side is open circuit and the right side is short circuit. So we will move towards the generator from open because our stub is in open. Okay, so our YL is 0.339. Okay, 0.339. Okay, so we move towards generator. So we will start from 0. Okay, we will start from 0 up until 1. Okay, from 0, let me draw to you. From 0, okay, towards generator, so we will move this side. Okay, from here, okay, move along until we reach our YL. Okay, a bit shaking there until we meet our YL. So this is our L. Okay, the distance or the length of our stub. Okay, so it will be from 0. Okay, because start from open circuit, so 0 up until 0.339 lambda. So the value of our L, okay, the value of our L, Let me write it this way. Okay, number 5. Okay, we're going to rotate. We're gonna rotate open circuit Y, open circuit to YL. Okay, so we're gonna use wavelength towards generator. So Y open circuit is equals to 0 and YL is equals to 0.339 lambda. 0.339 lambda. So our L is equals to 0.339 lambda minus 0. So we get 0.339 lambda. Okay, there's another way that we can use instead of moving our rotation wavelength towards generator, we can use wavelength towards load. Okay, so wavelength towards load. Okay, wavelength towards load is this direction. It's in anti-clockwise. Okay, wavelength towards load. So we're gonna read our second scale here. Okay, so it will be here, somewhere here. So this value is 0. See, 0.17 is here. So this one is 0.16. So it's in the middle. So I will take it as 0.161 lambda. Okay, 0.161 lambda. Okay, so moving towards towards the load, our open circuit is still at the same position here, but our direction of moving, it will be in anti-clockwise. Okay, it will be in anti-clockwise. So you have to start from here, 0.161 lambda, and you're going to move anti-clockwise up until our Y short circuit here. Okay, so it's not 0 anymore, but it's a 0.5 lambda. Okay, so I'm going to use the same. Okay, rotate YL to Y open circuit, but this one I will use wavelength towards load. Okay, so Y open circuit now is not 0, but it will be 0.5 lambda, and our YL is not 0.339, it is 0.161 lambda. 0.161 lambda. So our L is equals to 0.5 lambda minus 0.161 lambda. So you will get 0.339 lambda. So if you notice, you will get the length, the value of the length of the stub is the same. Okay, both will get 0.339 lambda. So it doesn't matter if you want to rotate it in towards generator or you want to rotate it towards load. It's just that you have to know where is our open circuit. Is it in 0 condition or is it in 0.5 condition? And you must read your reading is in generator or towards load. Okay, so I hope you can understand open and shunt stub for today. Enjoy. Thank you.